Backfeeding electrical panels is a dangerous practice that can lead to tragic consequences. Connecting a generator to the panel's output terminals can energize the electrical system without the utility's knowledge, creating several hazards. Firstly, electrocution. If a lineman or another electrical worker attempts to work on the system while it's backed, it can be electrocuted. Secondly, fire. If the backfeed is not properly sized or installed, it can overheat and cause a fire. Thirdly, damage to equipment. Backfeeding can damage electrical equipment, including the generator, panel, and appliances. Instead of backfeeding, there are safer alternatives to consider. One alternative is using number 12 American Y-gauge extension cords. These cords can be used to connect the generator to individual appliances or devices. Another alternative is manual transfer switches. These switches allow you to safely isolate the electrical system from the utility and connect it to the generator. It's crucial to avoid backfeeding panels due to the inherent risks involved. Following proper electrical safety protocols is important. Remember, your safety and the safety of others depend on it. A manual transfer switch is a device that allows you to safely switch between utility power and generator power. It isolates your home's electrical system from the utility grid when the generator is in use, preventing backfeeding. When selecting a manual transfer switch, ensure it is properly rated for the amperage of your electrical panel. Consult with a qualified electrician to determine the correct size and type of transfer switch for your needs. The installation of a manual transfer switch involves several steps. Firstly, turn off the main breaker in your electrical panel to disconnect power to your home. Secondly, mount the transfer switch near your electrical panel. Thirdly, connect the transfer switch to the circuits you want to power with the generator. Fourthly, connect the transfer switch to the generator. Fifthly, test the transfer switch to ensure it is working properly. When using a generator with a manual transfer switch, follow these safety precautions. Firstly, never overload the generator. Secondly, operate the generator in a well-ventilated area. Thirdly, keep the generator away from flammable materials. Fourthly, turn off the generator before refueling it. Fifthly, use a carbon monoxide detector in your home to protect against carbon monoxide poisoning. Extension cords can be a simple and convenient way to power individual appliances or devices during a power outage. When using extension cords, choose heavy-duty cords that are rated for outdoor use. Ensure the cords are in good condition and free of damage. Avoid overloading extension cords, as this can cause them to overheat and create a fire hazard. When using extension cords, keep them away from water and other potential hazards. Always plug extension cords directly into the generator and avoid using multiple extension cords connected together. Before using any electrical equipment, inspect it for damage and ensure it is properly grounded. If you are not comfortable working with electricity, consult with a qualified electrician. Consider the wattage requirements of the appliances and devices you want to power with the generator. Choose a generator that has enough capacity to handle the load. The wattage of an appliance is typically listed on a label on the appliance itself. When calculating the total wattage, add up the wattage of all the appliances you plan to run simultaneously. It's always better to choose a generator with a slightly higher capacity than you think you need to account for unexpected surges in power demand. Portable generators come in a variety of sizes and power outputs. Choose a generator that is appropriate for your needs and budget. Inverter generators are a good option for powering sensitive electronics, as they produce cleaner power than traditional generators. When selecting a generator, consider the noise level. Some generators are quieter than others. Before using a generator, read the manufacturer's instructions carefully and follow all safety precautions. If you have any questions about generators or electrical safety, consult with a qualified electrician. Understanding basic electrical concepts is important for ensuring your safety when working with electricity. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of electrical current. Ohm's law states that voltage equals current times resistance. Power is the rate at which electrical energy is transferred. Power is measured in watts. Electrical circuits can be either series circuits or parallel circuits. In a series circuit, the components are connected in a single path. In a parallel circuit, the components are connected in multiple paths. Grounding is the process of connecting an electrical circuit to the earth. Grounding helps to protect against electrical shock. Circuit breakers and fuses are safety devices that protect electrical circuits from overcurrents. When an overcurrent occurs, the circuit breaker trips or the fuse blows, interrupting the flow of electricity. Always replace a blown fuse with a fuse of the same amperage rating. Never try to bypass a circuit breaker or fuse. If you are unsure about anything related to electrical safety, consult with a qualified electrician. Regular electrical inspections can help to identify potential hazards and prevent accidents. Keep electrical panels and outlets clean and free of obstructions. Avoid running extension cords under rugs or furniture. Replace any damaged electrical cords or outlets immediately. Be careful when working with electricity near water. Never use electrical appliances in the bathroom or near a sink or tub. If an electrical appliance falls into water, do not touch it. Turn off the circuit breaker or unplug the appliance before attempting to retrieve it. Teach children about electrical safety and keep electrical outlets covered with safety plugs. If you experience an electrical shock, seek medical attention immediately. Electrical safety is everyone's responsibility. By following these safety tips, you can help to prevent accidents and protect yourself and others from electrical hazards. Remember, when in doubt, consult with a qualified electrician. Manual transfer switches offer a safe and reliable way to connect a generator to your home's electrical system. There are different types of manual transfer switches available, each with its own advantages and disadvantages. A single-pole, double-throw switch is a simple type of transfer switch that can be used to switch between utility power and generator power for a single circuit. A double-pole, double-throw switch can be used to switch between utility power and generator power for two circuits. A multi-circuit transfer switch can be used to switch between utility power and generator power for multiple circuits. Some manual transfer switches also include a built-in generator interlock, which prevents the generator from being accidentally backfed into the utility grid. When choosing a manual transfer switch, consider the number of circuits you want to power with the generator, the amperage rating of your electrical panel, and whether you want a built-in generator interlock. It's always best to consult with a qualified electrician to determine the best type of manual transfer switch for your need. The National Electrical Code, or NEC, provides guidelines for the safe installation and use of electrical equipment. Article 702.4 of the NEC covers optional standby systems, which include generators and transfer switches. This section specifies the requirements for the transfer equipment. The transfer equipment must be suitable for the intended use and must be installed in accordance with the manufacturer's instructions. The transfer equipment must also be listed and labeled for use with generators. Article 700 of the NEC covers emergency systems, which are required in certain buildings, such as hospitals and fire stations. Emergency systems must have a reliable source of power, such as a generator, and must be designed to automatically transfer power to the emergency loads in the event of a power outage. Consult the NEC for specific requirements related to generator installations and transfer switches. It's important to follow all applicable codes and regulations to ensure the safety of your electrical system. When working with electricity, always use the proper personal protective equipment, or PPE. This includes safety glasses, insulated gloves, and appropriate clothing. Before working on any electrical circuit, turn off the power at the circuit breaker or fuse box. Use a voltage tester to verify that the power is off before touching any wires. Never work on electrical circuits while standing in water or on a wet surface. Avoid wearing jewelry or other metal objects when working with electricity. If you are not comfortable working with electricity, consult with a qualified electrician. Electricity can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock. Ground fault circuit interrupters, or GFCIs, are safety devices that protect against electrical shock. GFCIs monitor the current flowing through a circuit and quickly interrupt the power if a ground fault is detected. Ground faults occur when electricity flows through an unintended path, such as through a person's body. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Test GFCIs regularly to ensure they are working properly. If a GFCI trips frequently, there may be a problem with the circuit. Have the circuit inspected by a qualified electrician. Arc fault circuit interrupters, or FSIs, are safety devices that protect against electrical fires. FSIs monitor the current flowing through a circuit and quickly interrupt the power if an arc fault is detected. Arc faults occur when electricity jumps between two conductors, creating a spark or arc. Arc faults can be caused by damaged wiring, loose connections, or faulty appliances. FSIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Test FSIs regularly to ensure they are working properly. If an FSI trips frequently, there may be a problem with the circuit. Have the circuit inspected by a qualified electrician. Surge protectors protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage sensitive electronics. Surge protectors divert excess voltage away from the equipment and into the ground. Surge protectors are available in different sizes and configurations. Some surge protectors are designed to protect an entire electrical panel, while others are designed to protect individual appliances or devices. When choosing a surge protector, consider the amount of protection you need and the type of equipment you want to protect. It's a good idea to use surge protectors for all sensitive electronic equipment, such as computers, televisions, and stereos. Electrical fires can be caused by a variety of factors, including faulty wiring, overloaded circuits, and malfunctioning appliances. If you suspect an electrical fire, turn off the power at the main breaker or fuse box. Call the fire department immediately. Do not attempt to put out an electrical fire with water. Use a fire extinguisher that is rated for electrical fires. Keep a fire extinguisher readily available in your home. Inspect your electrical system regularly for potential fire hazards. Replace any damaged wiring or outlets immediately. Avoid overloading electrical circuits. Use caution when using extension cords. If you have any concerns about electrical safety, consult with a qualified electrician.